Assalamualaikum and hi. We are from Group 9, from Section 9. We'll be presenting to you about our group project for GEOTECHNIC 2. So this is our group members, which is Akil, Umi, Rabiata, and me, Wanuriliana. Okay, so this is a little bit of introduction about soil mechanics for this study. Soil mechanics embrace the study of all those properties of soils that are related to their behavior and its application as an engineering material. Soft clays belong to the well-known category of problematic soils. Such soils are mainly encountered under layer deposit in coastal areas. The lack of bearing capacity, high compressibility, and very long time of consolidation are three typical properties of soft clays. Several problems related to soft clay exist from field investigation to their modeling behavior. To minimize disturbance effect on soft clays properties in situ test is a possible solution. As an example, the field vent test is usually performed in upper soft clay layers less than 10 meter depth to determine the profile of undrained cohesion. Okay, the next one is our study objectives that we need to achieve while doing this study. The first one is to determine the characteristic of soil. The second one is to investigate the case study of, at the soil in Malaysia. And the last one is to determine the application of soil stabilization in soft soil. So based on this study, we got to achieve our objectives successfully.
Good day everyone, my name is Aija, CF220179. Now I will be continuing the presentation with the case study. So for the characteristic of the soft soil, we know it has a high water content, low bearing capacity, high compressibility, poor permeability, and shear strength typically less than 40 kilopascal. So the below table has shows the shear strength data that we obtained for the wind shear test at the research center of UTHM to prove and show the evidence of the characteristic of the soft soil. So from the table that we know, we have taken 2-meter depth by using the wind shear test, and we can conclude out that the soil have a very sensitive in the surface and less sensitive in the deep depth, as shown when we looking at the peak shear strength data vary from 0.5 meter to 2 meter. So, and then we also can prove that the soft soil have an undrained shear strength, which the soft layer at the surface and stiffer at the deeper depth by looking at the peak shear strength value, which is 30 kilopascal for 0.5 meter and 34 kilopascal for 2 meter. At the end, we know that from the data, the soft soil have a low bearing capacity as the shear strength in this 2 meter is less than 90 kilopascal. So to deal with the reality, let's look at two case studies that related to the soft soil issues. For the first case study is Hospital Tengku Ampon Rahimah Integration Quarters in Klang, Selangor, which have a soft soil condition of very soft to soft silty clay, which poses to the high compressibility and low shear strength issues. Causes to the construction issues of unstable of ground during the construction due to the lack of ground treatment work. And this have bring to the impact of project dilation and also the overspending. The second case study is Polytechnic Kota Kinabalu Core Facilities Building in Sabah, which has a soft soil condition of high compressibility and poor shear strength, causes to the post-construction settlement. And this all occurs is because of the improperly implementation of ground improvement measures that causing the failure to reduce the dangers connected with the soft soil. To conclude up, the both case study has exposed to the soft soil issue, which indicate that the proper ground treatment before the construction is essential to mitigate these kind of challenges. So soil stabilization can be one of the applications in order to avoid this kind of issue occur.
Assalamualaikum, my name is Umi Hafsah and I will present for the chapter 3, which is application. We know from the previous chapter that present by the Miss Ng, it is concluded that the site chosen is at Research Center for Soft Soil, and from the test that we did, which is from the venture test, we know that the structure of the soil is the soft soil. So now we're gonna move to which method for the soil stabilization in order to support the pavement and also the foundation. So before we begin, I need to explain what is soil stabilization. Soil stabilization, it is a process of altering the physical properties of soil, and it can increase the shear strength and also control the shrink well property of soil, thus improving for the load bearing capacity of subgrade. So for the soil stabilization, we have a various method, which is mechanical stabilization, lime stabilization, cement stabilization, chemical stabilization, grotin stabilization, and also geotextile and fabric stabilization. For the first method is mechanical stabilization. It requires physically altering the soil properties such as its porosity value, permeability, plasticity, and many more. There are few techniques for the mechanical stabilization, which are compaction and soil mixing. These two are commonly used in the construction site. For the compaction, it is when the machinery compacted the soil to reduce the porosity, which makes the grain hold onto each other and increases its density. It is a common practice that we use the heavy weight to pound away irregularities of the soil and ensure a consistently compacted surface. There are various ways to compact by using machinery. There are few types. There are two types of the machinery that they will use to compact the soil, which are big roller machinery and plate compactor. They will use either one, depend on the size of the perimeter of the site. If the site is bigger, they will use the big roller machinery. But if the small area, they will use plate compactor. For the second technique is soil mixing. Soil mixing is a technique to mix in situ soils with other soils from other locations with different properties to enhance each other. So that means the soil, it combined with two or more soils of various grade together. For non-binding cohesive soils, they add an amount of fine materials such as clay or silts. For the second method, it is a lime stabilization. It enhances soil properties by mixing lime into the soil, which acts as a binder that reacts with clayey material that harden over time. So the lime itself that transfer in the construction, it is in the powder or solution form. The lime stabilization contain the sulfate content and also the organic material. It improves soil strength, reduce its water content, hence reduce its plasticity. When lime combined with clay, it will react with soil particles and permanently transforms clay structure into strong cementitious materials. And it will also reduce the water content in soil and plasticity of the clay, which allow engineer to compact the treated clay very well. This makes this method is very suitable to soil type which has a lot of water content in it, such as clayey soil. For the third method is cement stabilization. As for the cement stabilization, the approach is quite the same as lime stabilization, except it is use other additives. Typically, the Portland cement is used as admixture into the soil to improve its soil properties. By mixing the pulverized soil and Portland cement with water and compacting the mix, the soil cement becomes very hard and durable structural material as the cement hydrates and develops strength. Cement stabilization done while the compaction process is continuing. During the compaction process, they use some amount of cement. In soil particle, they contain a void space. By that means, the cement fill the void space of soil easily. So, as a result, the void ratio of soil may reduce. After this primary task done, they add water in the compaction. The cement react with water and becomes hard. So, unit of weight of soil also may increase because of the hardening of the cement. Shear strength and bearing capacity will be increased. Because of the stabilization, permeability of soil may decrease. It has the same advantages as lime stabilization, except it is much stronger compared to lime stabilization. From the aspect of the immediate compaction, for better distribution, higher strength at a higher dosage, and better performance in certain soil types, such as coarse grain soil, where it can provide significant strain gains. In contrast, for the lime stabilization, it may be suitable for the higher plasticity index clay soils.
Hai and Assalamualaikum. My name is Muhammad Alakil Afzan bin Muhammad Arifin. I am from Group 9. I will present about the application of methods that we have studied in our case study, that I will continue from my group mate Umi Hafsah. Another 2 methods other than the 3 methods she has mentioned. So firstly is chemical stabilization. It enhances soil properties by additives which can alter the physical and chemical properties, just like cement stabilization. Cement and stabilization and lime stabilization is almost the same method approach to alter the soil properties. So chemical stabilization comprehends 2 of them inside one method, which is called chemical stabilization generally. So any additives that added into the soil layers is called as chemical stabilization. Example of chemical properties: it can change its pH value of a soil, which then may affect the electroconductivity of a soil to provide effective grounding for a building in case of electrical hazard in safetiness of a building. Also, another advantage of using chemical stabilization is easy to monitor, as this method will only need engineers to monitor it on the early stage in inserting the chemical additives, and during the end process, which we monitor the product or the result of chemical additives inserted in the soil layers. Another method is grouting stabilization. This method is widely used to stabilize existing building structure or structure which experience declining of soil strength due to external factor, or for examples, there are limestones that is being eroded by years underneath a foundation. So in order to fill that void, we can use grouting stabilization to inject grout materials in the voids that occur or present at the moment. It involves injecting grouting materials into soil layers to improve their physical properties, just as I said just now. This is a versatile method. It can get with chemical stabilization. Both chemical stabilization and grouting stabilization can be used in wider range, not just like lime and cement stabilization, which they preferably be used in the clayey soil or high moisture content soil. It is grouting stabilization got precise application to stabilize. It also one of the reason it is effective, which most stabilization method lacks. So for grouting stabilization, it focus on one area, one particular part of the foundation that experiencing declining of soil strength. So by using this method, we can prevent any failure, toppling or rotating of the existing structure. So we have come to the last part of this chapter, application, which is method of choice that we chose to apply in our case study, which is to stabilize soil in recess location in UTECHNIC. So from all of the methods we have presented just now, chemical stabilization is the most suitable method to approach this problem. It has a rapid improvement criteria, which it is not almost instantaneous, but it is a rapid improvement that we does not require any mechanical compaction or soil mixing, such as mechanical stabilization method, which approach to alter the physical properties by mechanically. But with chemical stabilization, is rapid and fast by adding additives inside the soil layers, injecting it, and then we just wait for it to react with all the minerals inside the soil layers, and it will alter the physical properties and chemical properties of a soil. It is very effective and versatile for any depth of soil layers, as clay soil is very sensitive with its moisture content, which is clayey soil is heterogeneous. This means that clayey soil is unpredictable for its layers. Furthermore, we only have 3 meters data of recess soil layers strength, and also we only got shear strength value, so it is relatively insufficient for us to choose any specific method approach to use in this recess location. But by choosing chemical stabilization, it is a safe option that we can versatile by choosing which chemical we're going to use for the soil layers. It does not require heavy work, just like I mentioned. It does not require mechanically involvement in changing the physical properties of the soil, which then it will not disturb the build structures around it. It is wide choice of additives to choose from, just like I said just now. So chemical stabilization is the method we choose to apply in recess soil case study. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rabiatul Adawiya binti Ismail with the metric number of CF220098. We will present about conclusion. Soft soil refers to a type of soil that is unstable under its geotechnical condition, characterized by low underlying shear strength and high compressibility. Soil stabilization is the process of increasing the strength and durability. For construction purpose, it is important to improve the strength of the soil in order to increase the life of structure. For this case study, the most suitable method to be used is chemical stabilization, as it doesn't require disturbing the soil layers. This method is to improve the weak soil, which is usually in the areas that need infrastructure development, but it also requires careful consideration of the soil type, chemical composition, and environment impact to ensure it is an effective and safe application to be used in the project. I think that's all from us. Thank you.